Hey folks, how you doing? I'm Dr. Sigmund, chem teacher here at Carl Place, and we're here with our entire chem department behind our great filmer here. And what we have here is a tank of liquid nitrogen that we rent from a local business, Westbury Welding. We've been doing that since I got here, so for 20 years, thanks to Mr. Joe Malizia, who always said and approved it. And what this is air, or the nitrogen part of the air actually, chilled down to a liquid. All right, and I'm gonna just turn this on just to, show you what's in here. It's about 225 gallons. Normally these big tanks go to hospitals. They use liquid nitrogen for various organ freezing and dermatological things to remove little warts and skin cancers and things like that. Preserve samples if they're doing some research on it and you want to find out what it is. Anyway, we rent this and we use it to demonstrate how gases behave, how typical gases behave, and then we kind of make some of the best ice cream the kids ever had or have had. So this usually takes up about 2 periods. So I'm just going to turn this on right now and squirt it in the air. Back in room 107, our normal chemistry room, at least one of them anyway. And what I have here is a small tank that big tank will refill. This small tank, or Dewar, it's called, D-E-W-A-R, is filled up, and I'm going to just fill up this beat up but safe to use styrofoam thing. Again, this stuff will come out looking like liquid, and then we'll do some experiments with it. I'm going to move this thing when it's pretty full onto my desk. All right? All right, hello again. We're back in the room. Here is the liquid nitrogen sitting in this container, and all right, that's my breath, my hot air breath condenser. All right, now I'm going to take some out and do a few demos. Folks, we normally do a lab here. It's an old Newsday article actually about liquid nitrogen, and then inside the lab that we do with the children are a bunch of things that will show the different properties. All right, so we're just going to start running through this, and I'm going to pour some liquid nitrogen into a Pyrex beaker. That's this right here, or flask actually, and we're going to observe what's happening to it. Now this stuff is not poisonous at all. It's just the nitrogen from the air, but it is extremely cold. And if this were all that you breathe, there wouldn't be any oxygen either. So, it's important to have, in a normal room like this, there's no problems. But if you were in a very closed space, you'd want some ventilation, because there would eventually be less and less oxygen in the air. All right, now I'm going to use a regular styrofoam cup to grab some of it. And for a short time, I can hold the cup before that gets too cold. I'm going to pour that right into this round flask. And you folks can see it's boiling. All right, what's pretty amazing, and it stumps the students for quite a while, if you think about it. How could something this cold, and you'll see how cold it is, be boiling? All right, and that's the question we always ask the students. And some of them say, yeah, it got real hot real quickly, or they're, it's not really cold. It's cold. You can hear it, and it's boiling. And the answer is simply that the room temperature is above the boiling point by about 400 degrees. Just like if you put water on a stove, you see the water sizzle around, that's because the stove is so much hotter than the boiling point of the water. When something boils, it goes from a liquid to a gas. Now, all this stuff you see on the side here is condensation that occurred. And there's still some liquid nitrogen left, but it stopped boiling because it made the glass so cold. It didn't boil anymore. But if I tilt it, that little bit that's left in there starts boiling again. All right? Okay. List some of the properties. Obviously, it has no odor, no taste, no color, and looks kind of like water. In fact, if you put your hand in, I can't keep it in any longer than that. It starts to sting and burn. That's how cold this is. But you hear it bubbling, and my hand comes out totally dry. There's no water here. In fact, this turns to vapor. That's it. You can't keep it in half a second longer. I'll get frostbite. That's how cold this is. In fact, it's already like, woo, tingly. All right? Now, let's see with a small amount of water in it. I got some water here. And I'm gonna pour some liquid nitrogen right on top of it. Now, this is one of the way they do this in the films. All that fog, like in the spooky films and everything, they could either use this. Normally they use carbon dioxide or dry ice. This is much colder than dry ice. A couple 100 degrees colder than dry ice. All right, but what's happening is the liquid nitrogen is floating on top of the water. It's less dense than it. And all that smoke and everything, that's the water vapor condensing. And of course, when things condense, they get heavier, and that's why it's all just piling down. The stuff is colder than the air, and we all know that things that are cold will sink, and things that are warm will rise. Now, Jake, if you could come over here, my friend, take a look. There's ice already. All that water is almost frozen already on top. I don't know if you can see that there, but I have a full layer of ice already. In fact, that's how quickly this will just take regular water and freeze it. All right, let's do some fun stuff. I'm going to take a bowl, good old racquetball, and I'm going to put it in here. And Janine, when it's cold enough, you can put on that glove if you want. You have to wear a glove to get the ball out. And what do we do with those gloves? You have the gloves? Did I leave them inside? Might have. And you're going to take that ball after it bubbles around a little bit. Yeah, take a picture of it. And throw it on the floor and see what happens. I left them inside. All right, now while that's waiting, takes about a minute. I'm gonna notice all the ice that's still there. All right, I'm gonna take another or some more of the liquid nitrogen, and I'm going to take this tube. It's got antifreeze in it, all right? That's what you put in the radiator of cars, just a small amount. And antifreeze means it doesn't freeze, right? You can see it's that greenish yellow liquid. I think I've used this test tube for the last 20 years. All right, and I'm gonna just let it sit in the liquid nitrogen. And sure enough, the test tube is so much warmer than the liquid nitrogen, it starts making the liquid nitrogen boil away. Okay, you can see bubble, bubble, toil and trouble. All right. Janine, if you don't mind, pop over. I think we're good to go. Grab that ball and throw it on the floor. Thank you. As folks, you can see it breaks like glass. Of course, the kids get a hold of the rubber. Safe to touch, but it's too cold to hold. And they pick it up and they go, ah! You know, it's chilly, and it does warm up and gets flexible again. All right? Let's do another demonstration. Got some beautiful flowers here. I got at Trader Joe's. And we're going to see what happens when we put them in the liquid nitrogen. Dr. Leffler, would you like to come along and put our flowers in the liquid nitrogen? And I learned the hard way, it's good to hold the garbage can underneath it. Dr. Leffler is going to take those flowers and just put them in. Okay, and it's not what you want to give your wife after you got into trouble. Anyway, it breaks like glass, and that's because all the cells froze instantly with the water. It's mostly water in these things. And I learned the hard way to try to hold the garbage can underneath it, so that I missed. Gotta do some cleanup after. Folks, here is the antifreeze. Didn't take this long to freeze it, and you can see it ain't very anti right now because it's frozen. Okay, this liquid nitrogen is a couple hundred degrees colder than with the antifreeze freezers. We don't have to worry about it because other than maybe the coldest part, like a Minnesota on a real cold day. All right, so we're gonna just let this set aside. And Jake is going to now come along. We're gonna take a regular hard-boiled egg, got them at Trader Joe's, pre-cooked and peeled, delicious, delicious. And he's gonna set this up with some glycerin, put the egg there, and then we're gonna pour some liquid nitrogen in the beaker around the flask, all right? Jake, if you want, just take, it just screws off, I know it's a small bottle. Might want to put some on your fingers this way, because glycerin's safe to use.
Put it on my hand.
Yeah.
I just made it on my finger.
Yeah, just spread it around. Perfect. That's what they make gummy bears out of, right? Here's the egg. And just let it sit right on top. Thank you. And I'm going to pour a whole bunch of liquid nitrogen around it. And notice what's happening to the egg. What's happening to that egg? The liquid nitrogen is boiling away, bubbling away. Let's see if we can get this guy going. Can you see the egg is starting to get sucked down? Into the flask. Let's see if we can get that to do that. Sometimes the eggs take a little longer. I shouldn't be touching it because it warms it right back up. Get some more nitrogen higher up on it. Wasn't making a good seal. There we go. All right.
It's starting to go down.
You know what it was? It wasn't round. It had like a flat part, so some air was getting in. There it goes. There it goes. Okay. Now, folks, I'm going to take this latex glove and I'm going to,
That's utterly fantastic, Dr. Sigmund.
let me see if I can get, what happens is I got this little problem with this is it evaporates as soon as I squeeze it. Nah, you know what? Let me do it this way. There we go. All right, so I'm going to just take this glove and throw a little bit of liquid nitrogen in it, and let's see what happens. Now, as it turns back to a gas, Mr. Melizia, how utterly
Utterly fantastic.
fantastic. Right, as this turns into a gas, it has so much pressure behind it, it can blow up this glove. Just tough to get the enough in here. Let's see if I can do it this way. There we go. It tore through. I got it. There we go. And it just kind of blows itself up. Now, one more. Let's take a balloon and blow it up, which is plain old air. Tie it, and I'm just going to hold this. And this is all has to do with the fact that the colder something is, the colder a gas is, the less pressure there is, and the less space it takes up, the smaller the volume. So I'm just going to put this in here. They're not very cryogenic. Wow, that's cool. So anyway, you can see the balloon right here comes out. Put it on here, and what happened? All the air shrunk down to almost nothing, and as it warms back up, the balloon kind of blows itself back up to normal. So we do all these demonstrations for the students. Can we do this again? Yeah. And you can see at this temperature, the amount of air that's in the balloon really isn't that much. It's just the air pressure at normal temperature that blows up the balloon. There's very little air in it, actually. It shrinks down to almost nothing, and that feels good. It's nice and warm in this room. All right, folks, thank you very much. Hope you enjoyed our amateur video here, and this is some of the things we've been doing in chemistry for the last 20 years. Have a great day.